Welcome to this class. This session, we are also going to give an example on how to apply the Cauchy integral formulas. So here the problem. Evaluate the integral e raised power 2z divided by z plus 1 raised power 4 dz, where c is a circle in center at the origin and radius 3, i.e. we have this as our circle. So we have now to carry out the value of this integral. This one will be evaluated with the help of the second integral formula that we stated previously in the previous class. Because we are saying that the power here is more than 1. So the first thing is that remember, when we have z plus 1, this is a circle. If you measure from the origin, so this is the origin, 0, 1, 2, 3, 4, 5. So now this is how we define this z minus z naught. So when we have z plus 1, then it tells us this is a circle radius 1. So from the origin, so this is -1, -2, -3. It tells us that that value, that circle is within this bigger circle of the region defined by radius being 3. So therefore, which means that then the Cauchy integral formulas will work, because the point z equals to -1. Actually, this is what it means. The point z equals to -1. So if you draw a circle here of radius 1 unit, then it will be within this circle of radius 3 units. So that means that the Cauchy integral formulas work. So, note that the Cauchy's second integral formula states that the nth derivative of the function at point z equals to a is given by n factorial over 2 pi I integral of f of z over z minus a n plus 1 dz. So we have our integral is integral of e raised power 2z over z plus 1 raised power 4 and then dz. So one thing that you have to remember from this general definition is that if you make now the integral of f of z over z minus a power n plus 1 dz, the subject, then you simply have 2 pi I over n factorial, then nth derivative at a. So therefore, to evaluate the integral, we simply need to have our value of n and then evaluate the derivative of the function at the point a. So clearly, if we relate this denominator and this one here, z minus a n plus 1, if we compare it with z plus 1 and power 4, then n plus 1 equals to 4 implies our value of n is 3. And relate z minus a to z plus 1, it tells you that a is minus 1. So that our a in this formula is b1, our n will be, a is minus 1, n will be 3. So that we say this is the same as 2 pi I divided by 3 factorial, then the third derivative of the function at negative 1 for the value of n. Since our f of z is given by e raised power 2z, then we are supposed to find the derivative of this function up to the third order, which is not very hard to do. So the first derivative, using chain rule, differentiating the power, we have 2 e raised power 2z. Second derivative of this function, differentiate power again and pre-multiply, will have 4 e raised power 2z. And then third derivative of the function will be, actually can be written as this. Differentiating the power and multiplying, will have 8 e raised power 2z. So it tells us that now the integral of f of z, z plus 1 raised power 4 dz will be 2 pi I. So 3 factorial is just 6. And then the value of the function multiplying by 8 e raised power 2, where this z you put negative 1. So we'll have this, like we have 16 pi I over 6 e raised power minus 2. And then 16 divided by 6, 2 here, 8, 2 here, 3 pi I e raised power minus 2. So which you can write it as simply 8 over 3. So 8 pi over 3 e squared I. So this is the value of that integral. So thank you.